Hello, welcome to my master thesis presentation. My name is Vatne Martinsen, and today I will present to you the effects of increasing ocean temperature on metabolic rates and shoaling behavior of Gobiusculus flavescens. I have yet to hand in my final thesis, so there are still some analyses needed to be done. So first I will talk to you about the background for my project, like ocean warming and the two-spotted goby that we use. Then I will go through the setup and measurements for the experiments. Then I will talk a little bit about preliminary results and their interpretation, and finally some further research. So, the Intergovernmental Panel on Climate Change revealed in 2013 that more than 93% of excess heat has been absorbed by the ocean since the 1970s. Data from the United States Oceanic and Atmospheric Administration show that global sea temperature has had an increase of 0.13 degrees per decade over the past 100 years. A paper from 2012 published in Geophysical Research Letters revealed that deep ocean has absorbed 1/3 of excess heat 700 meters below sea surface. And studies from the 2013 version of IPCC's report predicted that by the year 2100, there will be an increase of global ocean temperature of between 1 to 4 degrees. So, the increasing ocean temperatures is nothing new, and we do have natural occurring fluctuations, which is due to changing seasons, currents, upwelling, tides, local topography, and solar radiation. But the extreme changes that we have experienced in the recent years tells us that this is not natural, but it is because of climate change. So, it is predicted that increasing water temperature will have a negative impact on the metabolic performance of aquatic ectotherms. And a consequence of this might be less energy available for important functions of fitness and performance, and can ultimately affect survival. Also, another prediction is that temperature might affect behavior. So for species that have a social structure, like shoaling and schooling, this will also be affected. So in order to examine the effects of increasing ocean temperature, we are using the two-spotted goby, which is a good indicator species because they are an ecologically important species for their marine ecosystems in the Northern Atlantic Ocean. They are a keystone species in the cod food web. They are good for lab experiments because they grow fast, they portray all the life stages within 1 year. They are easy to keep, they breed easily, they are less stressed, so they tend to show their natural behavior in a lab environment. So they occur all along rocky shores and kelp forests from the north of Norway to the south of Portugal, and they inhabit sheltered and semi-exposed shores, but they are less abundant in exposed locations. You can also find them in some places in the Baltic Sea. This particular population that we are using for this experiment comes from Arabida Marine Park, which is located a little bit south of Lisbon. So my research question is, are increasing ocean temperatures affecting metabolic rates and shoaling behavior for two-spotted gobies? The first hypothesis is that fish kept in higher temperature will have a higher metabolism and therefore experience slower growing. The second hypothesis is that fish kept in higher temperature will have a slower swimming speed compared to fish kept in ambient temperature. So this is the original setup. We had 1 to 2 fish per tank and around 100 fish in total when we started. We have extra aquariums for distribution after experiments. So every month we do experiments and then the distribution of fish will change. So that's why we also have letters and we also had numbers for each aquarium to then distinguish if something were to happen to a fish. The pink aquariums are the experimental groups, which have a higher temperature, and the blue aquariums are the control group, which have an ambient temperature. And the temperatures are matching the seasonal fluctuations of the collection site. So in the beginning, we started with 15 degrees in the blue ones and 18 degrees in the pink ones. So here you can see how it looked like in the lab, and there were also environmental enrichments in each aquarium, so some nests to make the fish more comfortable. So here are the experimental setup, and we did 6 measurements for growth, which was 2 times in January, and then 1 time in March, 1 time in April and May. And for metabolism experiments, we did only February, March, April, and May. And to slowly increase the temperature before day 0, also the start of the experiment, we increased temperature 1 degree per week up until this date. So as I said, when we started, we had 15 degrees and 18 degrees. And then to follow the natural fluctuation of temperature, by April, we had 16 and 19 degrees. So for the shoaling experiment, we had a 5-liter tank. We put 2 fish from 4 different aquariums, 8 fish in total that were from the same temperature group. They were acclimatized for 10 minutes, and then we recorded them with a video camera for 20 minutes. And here we want to see their behavior, so swimming speed and their nearest neighbor distance. And this video footage I have yet to analyze, so I don't have a lot of results for this yet. And for the metabolic rate, we had a 4-channel fire sting oxygen sensor that we used to measure the standard metabolic rate and the maximum metabolic rate. So the chambers looked like this. We had 1 individual fish in each chamber. First, we would let the oxygen flow through the chambers for 1 hour. Then we would turn off the oxygen flow, let the fish breathe to measure the oxygen consumption. And this is their resting metabolic rate or their standard metabolic rate. Then we would open the chambers, take out 1 individual fish in a big bucket, and then chase them around to simulate how a predator would chase them. This would be going for 5 minutes, then we would take the fish back into the small chambers. And because we had to manually screw up each of the small screws, to compensate for that time, we would let the magnet on the bottom of the chamber flow go to create a water flow to make the fish a bit more tired again. And then we would measure the oxygen consumption after they're tired. So this is their maximum metabolic rate. So what we're trying to find out by measuring the metabolic rates is to see their aerobic scope. So the aerobic scope is basically the difference between basal oxygen uptake and the maximal oxygen uptake. And if you go above or below a certain temperature, the aerobic scope will decrease. Then as the temperature rises further, less energy can be devoted to processes like feeding and reproduction, and this can therefore reduce their fitness. Then you can reach a critical temperature where the maximum capacity for oxygen is needed just to supply their basal oxygen needs. So again, the difference between minimum and maximum metabolic rate of oxygen consumption in unfed animals at rest is the aerobic scope. So when we wanted to measure the weight and height of the fish, we used a normal ruler, took a picture, put them in image J and measured them there. And for weight, we used this chemistry kind of scale for a very specific weight. And some preliminary results. So first of all, I want you to notice that the scale, the y-axis here goes from 0 to 15 for the standard metabolic rate or the resting metabolic rate. And on the x-axis, we have treatment. First one is the ambient, which is 15 degrees, and the second one is plus 3 degrees. So this is the higher temperature, which here is 18 degrees. So we can see from this data exploration that there are more variation in standard metabolic rate for the fish that are kept in higher temperature than the fish kept in the ambient temperature. We can also see that there are higher variability between the fish that were measured in April and May than the fish that were measured in so they were all measured in April and May, but there are more variability for the higher temperature than for the lower temperature group. We can also see that there is something weird with the March measurements for the higher group. So these values looks like they're 0, but they're just very, very, very small. And we're not entirely sure what have happened here. There might be something due to the oxygen sensors and something wrong with the chambers. And then we have some outliers, which I think also can be explained by something with the chambers, because we had a lot of trouble with the sensors. So we had to take out a lot of fish that we used. And here are the maximum metabolic rate. So again, I want you to notice that now the y-axis goes from 0 to 150. And again, here are the control group, here are the higher temperature group. And yeah, here again, there is very high variation between the fish that were measured for higher temperature and not so much variation for the fish measured in the ambient temperature. Again, we have some outliers, which I guess can be explained by the sensors, something wrong with them. I'm not entirely sure. We have to do a little bit more data exploration to find out. And here is the aerobic scope, which basically is the difference between the maximum and the minimum metabolic rate. That is why the graph is not really changed that much, because as you saw, the values are very small for the resting metabolic rate. So I would say it's the same comments as the last one. There are some outliers and a big variation here in relation to this one. And then for weight and standard length, which we'll see.
2 minutes, 2 minutes.
Thank you. Which will be the growth of the fish. There are no obvious pattern, only from the data exploration. So here I have the graphs for weight. Here is the graphs for the standard length. As you can see, there are not a lot of difference between the two groups in January and the baseline, because they had not been exposed for the higher temperature for that long, so that's normal. And then here you see it's like not a clear pattern at all. So again, we need to do more data exploration for this. And for the future research, I think it would be very interesting to see if increased temperature can affect the offspring of the two-spotted gobies, to maybe see if there are differences between the northern and the southern populations, maybe to compare with similar species. It would be cool to see studies where you have also ocean acidification and temperature, and to maybe see if there could be differences between the female and the male gobies. So thank you for your attention.